Hey guys, welcome to a new video on the Deep Cycle Power channel. Actually the Cell Doctor channel, I keep saying that. But in this video I want to talk about a patch, a hardware patch that I created for the old version of the Megacell charger. While working on the new device, the professional version, I was trying to find a way to make the voltage reading more accurate when I have discharging or charging current going to the cell. And after a few days, 2 or 3 days, trying to calibrate the device, done hundreds of reading at different voltages, I discovered something very strange, something that we did not cut up in the first version of the charger. We knew we had this MOSFET for reverse polarity, which was actually opened when a new cell was inserted, but we did not do the proper measurements at that time to find if the resistance of the MOSFET will change the voltage readings in some way, because the voltage reading IC that we have, it's connected to the main ground, and this IC is connecting the cell ground to the main ground. This created some voltage drop when we had current going or going into the cell or going from the cell. So I'm sorry for this. I did not cut this up at that time. We tested, we thought that the voltage drop was due to the ENA IC that we use for the current reading and voltage reading, because when it started to read current, the voltage will drop. So we thought, okay, this IC might have some issues, but that IC works very well. I tested it, and it's the voltage is right when you don't have the resistance of the MOSFET. So long story short, I created this PCB that it's an actually hardware patch. I'm sure you heard about software patches before. Now I've done a hardware patch for the old version, because I want to help those that want a bit more accuracy in their readings for the ESR, especially because that's where you need to know the voltage drop. When you measure the capacity, you don't care too much about that a few hundred millivolts voltage drop, because the IC will stop the charging or the discharging, and a few hundred millivolts doesn't matter that much. But when you try to measure the internal resistance of the cell, and our version is using the current drop method, the Ohm's law, to calculate the resistance of the cell, and we did not get the resistance of the MOSFET. And even if we had accommodated that, that resistance changes because the gate is not properly opened by the cell. Only when it goes above 5 volts, the gate, the RDS on, the resistance of the MOSFET, gets very low. Until 5 volts, the resistance is quite big, and it also causes the MOSFET to get a bit hot at high currents. For the first version of the Megacell charger, we're charging with up to 1 amp, and that did not create issues with its MOSFET. But when I started charging with 4 amps, that MOSFET was getting very hot, plus the voltage dropping. By the way, that MOSFET is rated for 20 amps, so it should hold 5 or 6 amps continuously with no issues, but it needs to have the gate properly open. So that's what this will do. I will go over the circuit, then I will show you how you can actually order this circuit directly from JLC PCB. I'm going to I placed an order already for 50 of these. and I will be sending to those of you that want this. You just have to pay shipping. I will be posting it for free on the Deep Cycle Power, and I will probably keep ordering these in the future. But that's the best I can do. I offer these for free because they are really cheap to make, but I cannot cover the shipping cost for these. 1 second. So yeah, I will show you really quickly how this gets connected. You see you have 3 pins right here, 3 inputs. You have the 5 volts. That's going to get directly connected to the power supply because the old version uses 5 volts power supply. You connect this with a wire to the plus of the 5 volts. Then you use ground, which is common. You can connect it directly with a wire to the ground of the input as well. And then you have the 3.3 volts. This I will have to make some pictures to show you exactly where to connect this, but I'll be waiting for this to come on, and then I will make a proper video assembling this on the PCB. So you can go ahead and get these devices if you want to place an order on JLC PCB. Maybe you have other projects you want to combine this with, and that will make it really cheap for one charger. It's like $1 or something like this. I paid it was $40 for 50 pieces, so it's less. It's actually less than $1 a piece, depending on how many you make. But that's because these I'm using LM393 ICs, which is a comparator. It compares the voltage, and it opens the gate fully with the 5 volts. Once that threshold is reached, I created here a voltage divider that will set the voltage to 0.7 volts. So any voltage on the cell that goes above 0.7 volts will trigger the comparator to open, and this pull-up resistor will get the voltage to 5 volts. So I don't want to go into the electronics part too much. I just want to explain how this is going to be connected to your board and how to order it for now. So you have C1 plus. You see that it's flipped because this gets mounted on the bottom side of the PCB. So cell 1 will be the one on the right. I arranged them this way, and also place proper text so you know where to connect the wires. You have the C1 plus, which goes to the positive side of the cell. You can drive a wire directly from the bottom connectors. Let me get one PCB to actually show you this. So this is the PCB, and you will get a wire from this one of these 3 points driven to the cell 1 right there. Same for the cell 2. You go to the cell number 2 right here, drive a wire to the C2 plus there. That's going to read the voltage, feed it into the IC, because this IC can support 2 comparators, so it will handle 2 cells independently. You don't have to plug one cell or have both of them plugged in to work. It's an IC with 2 comparators in it, so I used it for 2 cells. And then you have the the C2 gate and C1 gate. This is going to provide the voltage for the gate right here down. You see, so this is the bottom side of the PCB, and right here at the bottom you see a small resistor right here. I replaced that with one that's already on the board, so you don't have to do any fine soldering, but a wire must be connected directly to the gate of the MOSFET. So you remove this resistor right here, and then you connect your wire directly to the pin that's close to the gate. That's going to be a bit challenging if you're not seeing properly or you're not used to fine soldering, but I'm sure that most of you will not have any issues soldering to that pad. I do it under the microscope because I have one, but you can place some solder on that point there and put the wire coming from the gate. C1 gate goes to cell 1 gate, and the C2 gate goes to cell 2, and so on. So that's basically it. That's how you're going to connect it. Like I said, I did it in a way so it makes it easier, so you don't place any fine components. All the wires are driven here. So first I thought about creating small modules, so like a module like this, and then I thought, okay, that's going to create a mess. A lot of wires will have to be soldered from the power supply, the 3.3 volts, and yeah, that didn't make any sense to create the small modules. So I thought, okay, you will still want to do the whole charger. You don't have any reason not to apply this patch to the entire device. So I made this full PCB that you can glue or use some double-sided adhesive tape and place it on the back, and then drive 3 wires for the inputs, and then you drive the wires for voltage comparison and gate control. If you want this source file, I can give it. I can add it on the GitHub. If you want to modify it in any way, there's no secret in what I've done in here. And let me show you the schematic quickly. Maybe some of you want to buy these ICs or make the modification with the IC with a small PCB. You can actually do this with a big IC, because these come in THT as well, so through hole components, and you could have a breadboard or whatever. Yeah, this one. Let me show it to you. In the design for the patch, I use the SMD components, but you can get them like these with legs as well. It will be the same pinout, and you can see that it's U1A and U1B because it has 2 comparators inside. You can use one for both of them. You will have to create this voltage divider, which is basically a resistor, a 3.9K resistor connected with another 1K resistor, and in the middle you have 0.7 volts. If your VCC, the voltage input, it's set at 3.3 volts. I made the division from the 3.3 because some power supplies can go to 5.5 volts, and that will increase or decrease the voltage for the comparator. So I want it to be static at 0.7 volts to make it work properly. All right, so let's get on the JLC PCB. By the way, if you want to get the files for this, you go to the deepcyclepower.com, go into the documentation page, and then you have the patch. You have hardware patches here. Click here, and then you'll get to the GitHub where you can download the file. Click on code, download the zip. unzip it, and then you'll end up with something like this. So this is the bill of material, this is the SMT component placement file, and this is the Gerber files for the PCB. And I will show you quickly now on, you can see that I just placed this order. Merchandise total, so it was $46, and the shipping is $36 for this, almost the same price, but depending on where you live, or if you want to combine the orders, this can be really cheap. And like I said, if you want to get one for free, you will have to wait about 2 weeks. I think I will get the new components, and I will start shipping them to those that want it. I will place it on the website for free, and you can order from there. All right, so if you want to make these files, you go to add Gerber file or drag and drop. I think it works or not. Yeah, let's get here. You go to the folder that you downloaded, upload the zip file. After you unzip it, you don't upload the entire thing that you get from GitHub. You unzip it first, and then inside you'll find these files right here. All right, so if everything is okay, you should see a preview of the PCB. You leave everything as default. You don't have to make anything. You can change the color if you want to. If you want a red patch, you can get one. Then you go to the PCB assembly and tick it on. All the components are just on the top side of the PCB, so you can do it economically. You can leave this as economic. Here you set the number of PCBs that you want assembled. You can assemble minimum 2 PCBs on this website, and if you want to order more, let's say you make a combined order with other users, maybe in the USA, you could talk on the Megacell charger group and place an order, a combined order, so you can then ship it towards other people there. You need to specify the number of PCBs that you want to create. Yeah, for 50 you still are under the economy assembly. If you go above 50, you will get an extra fee for that. So if you want more assembled PCBs, you need to order more PCBs first, but I will leave it as default. I'll click on the confirm. Then it shows you a preview of the PCB. Click on next, and then you add the BOM file. BOM file is it's the bill of material. It's already made to work with the GLC PCB. I use their sample template to add the parts, so it's easy for you to add. I also added the parts that they have in stock for now, but there's nothing special. You just need to make sure. If you want other resistors, for example, you could make the division from 5 volts if you want to, or whatever. You will have to change some change the components in here, but you need to make sure that the the footprint is the same with the ones that are on the PCB. So right here it already selected the parts. You can see that for five PCBs I have a total payment of under $2 for the parts, so nothing expensive in here. Also, I fixed the file for the CPL, so you don't have to change anything in here. The components are properly aligned and rotated, because sometimes on GLC PCB they will have the offsets different from what you export from Altium or whatever editor you're using, but I changed that file to rotate properly the LM393 ICs. But you give it another look to make sure the components are in place. They have their checks as well. If it's not properly placed, they will contact you or fix it for you. You then click on next. You'll get the total price. So total price for 5 PCBs is $23. That will fix 5 chargers, and then you move on with here you just put the current sensor, save it to the cart, and then you go with the checkout. If you want to go with the cheaper side, if you want to just get the PCB and you want to do the manual soldering and order the parts separately from Mauser or another from DigiKey, you could do that as well. So you get it cheaper and then you do some manual soldering. It can be fun if you want to do that, but I prefer focusing on what I have to do and let others do this kind of fine jobs if it's possible. If I have to do it, I do it, but if I have another option like this one, pay $18 to get them assembled, yeah, it's not a big deal. So that's about the patch. That's how you order it, and I explained it how you assemble it as well. I will make another video actually assembling it and comparing the results we get for the voltage drops when I receive these new boards that I ordered today. So yeah, that's about it for the patch. I will give you a quick update on the status of the Megacell charger production. Let me see where I put those videos, because I have Powerwall product design. Alright, here are some photos that I received from the manufacturer. This is how the new board is going to look. And of course, the change, the patch that I just explained it will be contained in the new version of the Megacell charger. This one doesn't have it because I just made it yesterday. I finished making the patch for the main board, and then today I made the one for the older boards so you can use it as well. But these are the prototype boards with the new ICs for controlling the PWM of each cell. So you can have the constant current and constant voltage. I already implemented those in the software. I worked for the past weeks on the software and implemented those to keep the current there, keep it at 1 amp. If you say 1 amp, it will keep it at 1 amp, or whatever you're setting. It works very well. I enjoy how the new hardware works with the constant current, especially because that's how we want to test the cells. You apply a load that stays constant. The graphs will be much nicer this way. You will not see the current dropping, because before we had the constant resistance on, and if voltage dropped on the cell, the current also dropped, because if you want to maintain a certain current, you need to increase the resistance while the voltage drops, so you get to the same current. So these are the photos of the new PCB, and there will be another iteration with the patch that I just explained. But that's good. That's good. I caught this now. I will have to modify 5 of the PCBs that are for me, that are prototypes. I will put the patch that I created and use them as well. But the ones that I'm going to ship to the clients will have this already implemented in the PCB. so you don't have to worry. For those that pre-ordered this, I'm going to ship you the clean version. Not going to make any mods on them, because I would not like getting such PCB if I paid, or yeah, if I could have not done this, maybe well, to make it faster, maybe I would have done this patch, but with your approval. Otherwise, I would have refunded or explained that you have to wait a little more to get the final version. So this is how it looks, and I also got some videos for the production, which is always nice to watch. Let me see if I can add the sound as well, because the sound of the machine is also nice to hear. Here I add audio output capture, speakers. Yeah, let's see if this one is. So here, right here, for those that don't understand too much or what's happening, this is the pick and place machine, and the big white and black head that you see here, this looks like a printer, and most of the ways it's acting like this. It's more a CNC machine that has a special head that will get the IC from the bottom strips. Those look like this. So this is how you pack the components. This is just a strip, a small strip, but they place them on rolls, on big rolls, and it's just the head. It's sucking the component from those places and go to the place on the PCB to lay it down. So the vacuum stops, places the component there, and after that gets into the oven to transform that paste into solid solder, and then it goes to cool down, and then you get that actually. How fast. And it took me like 2 days to place the components on the first test board that I did. So 2 days versus a few minutes. That's very nice. So you see, it has some rolls in the back as well, so it will get components from the back and the front. This is a very advanced one. If you're searching on YouTube, you will see some pick and place machines, but the older ones will have just one head and go for each component at a time. But this saves time because it can load multiple components, and then when it gets to the PCB, it will drop them in different spots right now. Yeah, that's done. One side is done. You have two sides for this board, because we have components on both sides. And this is the electrical testing. So what happens here? They're measuring different points to calibrate a flying probe that's going to automatically test these points where it's setting them the values, because they are measuring the resistance now manually, and next is going to place them for the production boards. It's going to place them over a flying probe that's going to measure these points and compare it with the data that this operator inputted into the software. I can see that they are still using Windows XP or Windows 7. No, it's Windows 7. So
第481号，第120，
安祥音整 two. Alright, so this one is doing the optical inspection part. You can see it takes very accurate photos, and it will compare the shadows on the next one, so they know that okay, this one is good, this is how a good board should look like. And on the new boards it will compare it to the one that it was marked as well soldered, because if the temperature is not right, or if you have some big components, or if the PCB is not designed properly, some of the parts can top up, you know, they are not soldered properly, and this machine will catch it, because you have a few hundred components there. If you're just looking at it, you might not see the small components that are not soldered properly. So this machine will catch it, do it much faster that you can do it by eye, and then moves to the next. Right, not sure what is showing here, but it looks like it completed the process. So that's the update I have, guys, for the patch, and also for the production of the PCBs, for the new hardware, for the pre-orders that I still hope they are going to be shipped in September. I should not have a big delay. It depends how long it will take for DHL to ship these 5 boards, because what you watch now is the prototype boards of the 5 boards that I created to check that the new ICs for controlling the discharging, and also for controlling the BQ, the charging ICs, are working properly, and then I will give the okay to move on and produce the pre-orders that I have. So fingers crossed that we'll get them before the end of September, but if it's going to be 1 week, 10 to 15 days delay, hopefully we'll keep it just that. And right now it's out of my hands. I placed the order. I placed the order for the parts that I want to test, and also I gave the new changes, because they are just finishing the prototype boards now, so the new files will not create any delays. And I already tested that circuit. It's not a complex circuit anyway. I tested it on the PCB and modified. I put some wires on there to check that it works properly, so there will be no new prototype board for testing that part, because it's a simple circuit and it's already tested. It's not a big thing. So if you have any questions, don't hesitate to contact me on deepcyclepower.com chat. Go there or type it on here. Okay, I see I have some I only want the main board at this moment. Please put this video to YouTube, because I will see it. But you'll see it fully. You can go back in time and see it. How I can change my old PCB, because I'm leaving lots of problem with old devices. So this patch will help you improve the voltage, but if you're seeing other issues, you should contact me and discuss about that, because that's the issue. Like watch, pick and place processors. The new you will not be able to use the new main board. I don't know if you're referring to the main board as the PCB only, or uh, the the main board with the components on. That there will be no big difference in price if I sell just the board and you get the PCB. But yeah, I was saying that you can contact me on chat and also write me on YouTube, and I saw the chat there. All right, contact with me. Yeah, you just go on the deepcyclepower.com. I have that chat app right there, and you can write me directly. It's on my phone. It's like writing me on Facebook or whatever else, but it's more concentrated, and I can talk about just that. So, all right, guys. So, again, thank you very much for watching this, and I wish you all the best. I will keep you updated with the process of this, and I'll keep working on the software. I'm like 80% there. I got the main things done. I got the state machines. I got the PID set up for the constant voltage and constant current. And also the communication, the basic communication with JSON. I have to implement the other ones, the UDP and TCP. Not implemented, but modify them to work with the new setup that I created, because Martin worked on those. But I want to refine this firmware and find all the issues that are there with the measuring the ESR. That was the thing I was working on, measuring the conductor resistance. And then when I saw that the values I was getting, they were totally different from what they should be, because it was adding the resistance, and the resistance on those MOSFETs was changing depending on the voltage that you will input in them. And then it was a nightmare, guys. I chased ghosts for 3 days, and it was like 3 full days, 12 to 14 hours on working on this, doing different measurements to find where that goes from. And then when at some point I measured between the grounds, the cell ground and the ground of the input from the power supply, I saw the 100 millivolts difference that I was chasing. It's this one. I want this difference in my software. How do I get that there? And after doing more research, talking with my colleague Mihai that designed this circuit in the first place, and he told me, well, that resistance will change because the voltage you apply to the cell will make the MOSFET open more or less, so you have different resistance depending on the voltage you have on the gate. Oh, okay. I don't want that. I don't want to keep that in the new design. I need to fix it. And then I disassembled some versions. I said that I'm going to close this video, but then I reminded that I did this anyway. I was opening some Opus and Litho devices to see how they handle this part, and they just placed some diodes, the 3 amps diodes. They placed 2 of them in parallel, but that did not suit me because it was creating a 400 millivolts drop. It was constant. That was a constant-ish. It will still change from 300 to 400 depending on the current, but that was better than having it totally dynamic. Like it was from 100 millivolts up to 500 millivolts change when you go lower in voltage, like 2 volts, 2.5 volts. That MOSFET was halfway open there, and it was creating a huge voltage drop. I was placing 1.5 volts, and then I would read 1 volt with the ENA IC. And then I searched around, and I received the idea. I searched around to see what other solutions for reverse polarity, and then I saw the comparator, the LM393. And then I thought, okay, comparator sounds like it should be, like compare the voltage from the cell with the voltage threshold. I tested that. At first I thought there will be some issues with the ground not being connected, and I thought that the LM393 will not read the voltage if the MOSFET is not open, but it reads it fine, because the MOSFET allows some voltage to go back through it. It's like a diode. And it reads the voltage fine. It opens. The reverse polarity works fine. I tested it. There's no leakage in current, and also the LM did not break if you placed it in reverse, because at that point the LM will see just the negative of the cell. It's not seeing any voltage there. It will not open the MOSFET. So I was very grateful for finding this. It was late in night, like 11 or 12 a.m. And I saw, okay, this is linear, because right now I have like 15 millivolts. So from 100 to 500, I have like 15 millivolts per amp voltage drop, which is okay, because I can compensate for that in the software. I know the current that I know the resistance of the MOSFET, and I will compensate for it to read proper voltage when it delivers the voltage to the software. And when I make the calculations for the ESR, I will accommodate for the resistance of the MOSFET. But now the MOSFET stays fully on, because I drive it with the 5 volts. It's much better than driving it with 3.3 volts. The resistance, it's double, it's lower, double with minus. It's 2 times smaller than the resistance you get at 3.3 volts. So I will use that voltage for discharging as well, because there I have the same type of MOSFET. It will improve the resistance there as well, from like 30 millivolts voltage drop. It gets it to 15 per amp, which is okay. Like I said, it's going to prevent the voltage drop from being dynamic, because the MOSFET stays fully on, and it's also going to improve the conductivity of that MOSFET, not getting it that hot anymore at high currents. Like I said, in the first version, we had just 1 amp charging and 1 amp discharging. That was handled by the MOSFET with no issues. But at 4 amps, I was seeing some heat generated by that MOSFET, which should not be there, because it's a 20 amp MOSFET, so it should handle that. But if it's not properly open, then the resistance is high. Again, guys, thank you very much for watching. I thought it's going to be a short video, but I always find something to discuss about, because I kept working a lot on this charger to improve the efficiency of it, and also improve the usability and the results you're getting from it. Have a great day, guys, and thank you very much.